Hey now. So, get space. Woo. So, a little more about me. I have been in the Ruby community since 2004 with my character's name the entire time. I've been using Sidekiq for a long time as well, across several different companies. Like many of you, I learned Ruby by Wise Guide. And so, we were talking about it on Mastodon. Hey, do this shit, do the thing in character. So I am, and we'll see how this goes. Anyway, so the way that I set this presentation up is it's largely going to be the mistakes that I've made doing this for a long time, and some of them are really boneheaded mistakes, and so don't feel bad if you do that sort of stuff too. There's a lot of them I've done, a lot of mistakes I've made, but these are the top 7. And also I'm going to assume that you're familiar with Sidekiq, and if not, hopefully you can hang a little bit. This is really my opinion and not necessarily anyone I've ever worked for, just to put that out there. So what's the first lesson? Use a separate database. Don't do what I did. I've been using Sidekiq for a long time, and early on, it wasn't really well understood what would happen if you shared the database with Rails. And eventually made it to the wiki, and it's definitely never do that as the answer. If you can avoid it, whatever. So the reason for that is that, we didn't put the other database up because we're a startup and it costs money. And so why bother? And why would you want to maybe have a separate database? Well, you're going to need to scale out the Rails side of things, right? You're going to want to leverage clustering. You're going to want to leverage, having sort of isolation between the different databases and stuff like that. Sidekiq kind of doesn't really need that. It can work great with one database, no problem. And so what do, right? Well, you might try, if you want to use a different, Redis supports a different database index. So you could use the database index 1 and put Sidekiq there, and you're technically only running the one database, but that doesn't actually work because they still compete for resources. The clustering is configured more or less the same, and also a lot of different distributions of Redis or Valkey don't support number databases. So here's some ideas of how to fix this, or at least try to. So the brute force solution. What would that be, right? It's the simplest. Shut everything off, copy, paste. No, that doesn't work. You could do it if you can go offline, but that doesn't work at scale, right? So what's the second one you might try? Well, Redis replication, right? That kind of works. So, with this, it's like the job queuing never stops. You can still write, but you can't read. And you don't really have any user-facing downtime. But the way that this works is it leverages a sort of a feature/miss feature of Redis, wherein you can write to a replica, which is not a thing you normally would want to do. And so if you set it up that way and you write to this replica and everything's good, great, you've migrated over, no problem. Replication restart throws all your data away. So if you started to migrate your writes and they're about halfway over and the replication restarts, network went down, there's your replication buffer overfilled, whatever, you've just lost all those jobs permanently and you're never going to get them back. So that doesn't quite work. And of course, if you did get it to work the first way, you have to just immediately turn off replication and then take a snapshot and then, hope that it didn't fail at any point in that process. And that doesn't do it for you either, right? Also, another thing is not every provider gives you the access to use replica of. And in those cases, maybe you could use Riot, but maybe you can't. And, Riot's a thing that you can download from Redis, and it depends on the provider, but it may or may not work for you. So, what do, right? Well, we have to manually replicate. We have to do something. So, what we've done, or, I've talked with some colleagues about, is that basically just implement a manual replication process. And that's essentially what I'm going to go with. And this is also a high-level overview, but, sort of the keywords to think about if you're trying to think about this problem too, is we basically just, our pop will push the jobs to a new key and then use the sorted set commands to move them in batches and deal with Sidekiq Pro batches and all of that stuff. The whole idea is really that like there's not a step in the process that's going to result in data loss. That would definitely be a problem if that happened. And so you can always revert every step, yada yada yada. There's only downtime again is like you can't execute jobs, but you can queue them. So that's good, right? You also end up at the end state of like the source database and destination database are clean, and you don't have to remove any data that's left behind, anything like that. And I just anecdotally trying to advocate for open sourcing the migrator once we're done with it, but we'll see. I can't promise anything. So what's the second lesson? This one's really, kind of common knowledge at this point. Adam McRae at Judo Scale wrote a really good article about this called An Opinionated Guide to Planning Your Sidekiq Queues. And it's really good. It covers everything you need to know. Go search for that or, find him. I think he's here. Anyway, so the one thing I would say is like, you don't necessarily have to start with a gigantic cluster of Sidekiq processes. You do eventually need to have that as a thing you want to scale to. So think about it, like make sure you're prepared for it. Maybe like give yourself the provision for that in your, infrastructure orchestration, stuff like that. And of course, what happens if you don't do this, right? And this is the mistake that I made. You end up with queue blocking. So like something simple, like, okay, you have jobs that take tens of milliseconds. So you're going to queue those 10,000 jobs, like maybe sending activity emails or something. So you got those 10,000 jobs queued, but they're not going to execute because you've got like image processing or transcoding or something that take like a minute, and there's like a dozen or so of those. And that's just using all your resources, and you can't possibly run the things that are super fast. And you can't really use auto scaling for this because it takes minutes, sometimes 10 minutes or so to auto scale out. And, this sort of, when you run into this and you hadn't really, again, learned like I did, then you kind of get gun shy about like just fast or slow jobs, right? Like, maybe I don't want to write any slow jobs at all. And, that means that you start to model things in a way that are really unpleasant and would be better if it's just a long running Sidekiq job, right? So what I would say is like, I've done jobs that take half an hour, 2 hours sometimes, and don't be afraid of them. Just make sure they're in a queue by themselves. So the third lesson is to kind of a little bit contradict what I just said about using queues named after the SLA you want, but to fault isolate. And so this is like, think about like boundaries for like pack work, right? Or I guess pack work. Anyway, if you're going to modularize with pack work, then like you're already kind of drawing these boundaries, right? You're going to have different components and stuff like that. And you can think about your Sidekiq queues the same way, right? So you have your SLA-based queues, but you like prefix them with the name of the component. And you don't necessarily always do this, but this is a thing where you want to do that because these are going to typically be different, like Amazon ECS services that are all serving a different set of queues or whatever. And what you really want is for that to, how do I put it? You want the things to not necessarily be able to interact with each other. Like you might want to have different resources allocated, different CPU, different RAM, whatever. You might want to pack them more efficiently or less efficiently, depending on whether or not the job can technically go a little bit over its SLA, or maybe it can't, right? Like that's the thing that you need to think about. The biggest kind of important thing that is, I think, not thought about all that much is that the security context is important. And, my background is in information security. So this is what I think about at night sometimes. Anyway, so what's that mean, right? So what that really means is that like, you have like, Kubernetes pods or ECS services or whatever. Those are going to get different secrets assigned to them. Those are going to have different, on AWS, be an IAM role, whatever your cloud provider has. And, you kind of don't necessarily need something that's just doing image processing to be able to like read and write customer CRM data, right? Like, might not need that. And so you can restrict that at a level that it doesn't matter if someone could just upload an executable and run it, it doesn't do anything, right? Like you can't access that data or do anything bad to it. You could also use a restricted database user. Again, in the image processing example, you might say, okay, well, the image is going to get, you can only read write the images table and read a few others, and that's it. And so, this sort of, like I said, it limits the impact of remote code execution vulnerability. And the example I'm thinking of is Mastodon with ImageMagick. So if that were fault isolated in the way that it should be, then it would be only able to have affected images, right? Because you have the image processing is happening in a completely separate set of containers that are isolated from the others by virtue of the container ecosystem. It probably you could still escape. There's a lot of container escapes out there, but it's more difficult, right? You also can deal with the fact that some jobs might need to more aggressively or less aggressively scale out, and you need to have a knob to turn for that theoretically. And that said, fast iteration is most important when you're starting out. So really, this is more think about this, have this in the back of your mind when you're working on it, and kind of don't create extra tech debt for yourself. So they can go back in a future refactor and add this. So the fourth lesson is to ensure observability. And I will make a little bit of a, I don't know, admission. I don't run the Sidekiq dashboard. And originally it was because I didn't have the time to set it up to make it access restricted, and then I did, and I'd already set the metrics collection, so I didn't really need it. And then now, the company I'm at now got acquired by a big company, and we need to put SSO in front of it. It's more complicated, and still haven't done it. And Sidekiq Enterprise gives you a hook for a lot of this, but yeah, it's a lot of work. It's not a lot of work. It's just a little bit of work that doesn't necessarily bring all that much value at the moment. But regardless, if you're going to run the Sidekiq dashboard, don't make it internet accessible. Put it behind a Bastion host or restrict it to a certain IP address range or whatever. Don't put it on the internet. That's not a good idea. So in addition to the different libraries I have on the screen, you could also roll your own with Sidekiq stats. That's what I did, because at the time these didn't exist. And really, regardless of whatever system you're going to use to collect metrics, collect them more than once per minute. The reason for that is really pretty simple. It's that you don't want to just use one data point to make a decision on, I need to scale out, or something bad's happening, I need to page somebody. Right? You want a few, and you want a few over some time period, and that time period being 10 minutes might be the difference between having customer impact or not, right? And so if you can make that time to response be a few minutes, like 1 or 2 or 3, because you're measuring every 15, 20 seconds or something, that's way better than if it takes 10 minutes. Because if you think about the action is to scale out, scaling out, if you have to launch new instances, can take 10 minutes. And now, again, you're back to having customer impact if the jobs have to execute quick enough, right? So, you really, you really want to avoid, really want to keep track of that. One thing, though, is that it's going to require a little bit of special consideration, because usually high resolution metrics cost more and sometimes require you to use a different API to publish them or whatever. But, that's something that you can plan for accordingly. You can also think about APM, application performance metrics, right? And what I would say is that that's not going to be a way out. That's the mistake in this slide. Is you can't really rely on APM to tell you that your jobs are performing poorly, because it's going to tell you the code path is performing poorly, which might not translate to the job actually being bad, right? You might have a method that is not necessarily the most optimal it can be, but hey, guess what? It's still executing way faster than you need it to, and you don't need to care. So it doesn't frequently correlate, and that's kind of unfortunate, because usually you're already using some tool to do that. I think the sponsors, or one of them, is an APM provider, so you're using their tool theoretically. And if you are, awesome, and just probably want to also collect your own separate metrics for job performance, not just APM. But what do you have when you have metrics? What do you do, right? Well, like I said, you probably are going to end up paging someone in the worst case, and then in the best case, you have data to draw from to make decisions about how to scale the different Sidekiq, runners, workers, whatever you have. In the case of Amazon ECS, right? You have different ECS services, and so you want to give some more CPU and some less CPU, and it's how do you know which one's which? How do you know what is the best choice? Is you don't have to have the data, and by collecting the job performance metrics, you're able to figure that out. And then also it's how many different instances of the service are you running? How many different what's the Sidekiq concurrency set to? All of these are things that you can collect this data and then easily go compare later. Hey, this is good, this is bad. I'm going to make a tweak and make it more efficient. And okay, it still performs just as well. I'm going to continue to tweak that until I'm at my cost optimization goal or whatever, right? That said, for auto scaling, don't use CPU or RAM utilization as a proxy for the performance, like that you need to scale out or scale back in. Doesn't really work very well for that in my experience, and that's the mistake that I made here. And it's unfortunate because it's really unhelpful to have those be provided by default and you can't use them. I mean, I guess if you did nothing, I guess you could use them and that would be okay. But like it really, I would suggest just hooking up, wiring up auto scaling with some of your metrics you're collecting. So the other thing is, your scale in and out logic might need to be more complicated. And really the key thing is to eagerly scale out, but conservatively scale in. So the fifth lesson is to avoid the sharp edges. There's a lot of them, and I thought about making this like a whole bunch of different ones, but like then we're at like lesson 50 or something, and it's not worth it. The first thing I have on here is make the jobs idempotent. And what that really means is that sometimes you have a situation, say it happens 0.01% of the time at a certain scale, that's daily or hourly or, minutely for some folks. And so what might happen is that the job can do all of its work and commit the transaction to your RDBMS and everything is good. And then it can't mark it complete in Redis, that packet gets dropped. Sidekiq Pro will happily deal with that problem, but if not every situation would that still, like, there's still a possibility that it wouldn't necessarily be able to check the job back in as complete, right? And so what happens when that job gets recovered? Well, it's going to redo all the same work again, meaning if you didn't have any check for idempotency, that you're going to redo all of the work, you're going to duplicate rows theoretically. It might be at this point too late to do the thing you needed to do, and now you are creating like a exception that lives forever until you go clear out the dead set or something. So that's deeply unpleasant. So try to make sure that you're checking this when the job starts, and then or at least some version of idempotency, whether it's the checking the status is needing, you still need to do the thing or whatever. Another thing is like, file system in a containerized environment is weird because containers are going to have quotas, the system is going to have a quota. They're not necessarily going to be set to what you expect them to be, and they might need to be tuned or might not need to be tuned, whatever. You also might have it where each container has a volume for itself, or it might be there's a shared volume, and it's for the whole instance, and that's for like cache or something. And you kind of, those are all things to think about. But if you're going to use the file system and you don't really know what the configuration is, then you might end up in a bad situation. For instance, temporary directories, those are usually by default RAM disks nowadays. And so you're downloading, say, a multi-gigabyte file, which you think is going to a disk that you don't really care about the size of, but it's actually going to RAM, and you crash the container. That's not great. You don't want to do that. Ask me how I know that. So, think about that. Also, another thing that happens for me, a lot of my jobs are network hungry, not CPU or RAM bound, really. And so what do you do about that, right? Like the kind of thing you might initially think is, I'm going to go look at the product pricing page for my cloud provider and go, hey, how much does it, what is the performance level for the network here, right? And it's going to say up to a number. Well, don't do that. Instead, go to the documentation and find the minimum performance. Usually it'll be like there's a per flow rate and a peak, like a aggregate flow rate or whatever. Pick whichever one's smaller, and then use that to map to the CPU and RAM that are each instance type has, and then use that to kind of use CPU and RAM as a proxy for the amount of network performance you need, right? So like if you know that like I need to be on this instance serving 5 gigabits a second, it would be really bad to have jobs that could get scheduled on an instance that has a minimum performance that's guaranteed to you that is a megabit, right? Or 10 megabits or 50 megabits. Like that would be, you would clog up that instance's pipe really quickly, even if it might be able to boost to 10 gigabits per second or something. And, it's unfortunate you can't really, use that metric as a thing to you have to convert it to being CPU and RAM. You can't just use network performance. Also, like you might have a different networking strategy you want to use besides Docker NAT or whatever. You can do whatever, right? There's a lot of different choices out there. There are all different trade-offs. You might need to do some tuning for your cloud provider. There's all kinds of stuff like that. There's also some more sharp edges, and really these are how they affect customer impact, or how they create customer impact. And so I've sure that no one here has ever pushed a job out that or pushed a code change out that is a job that then suddenly is failing or not performing correctly, and then oops, I got to roll this back immediately. No one's ever done that. So I have. And so what I found is that it's really valuable to have, it'd be possible to have a key in Redis that you can just set, and then jobs with that class name don't run anymore. They just immediately fail. And you can use a super class basically that implements this or whatever. And Sidekiq also lets you pause queues, but being real, you probably have more than one job in a queue, and so that's really not helpful if you just pause the queue, because you're just still creating that customer impact. Again, you just can kill that job, and then while you make the job fail, it'll get retried, and then you can fix the code, deploy it, pull the key out, and then everything's good, and you've limited the customer impact of like one thing. You might also have jobs that get re-executed frequently, because like Clockwork or cron or whatever is going to start those jobs. Maybe if they fail, think about whether or not they need to be retried in the first place. You also should probably avoid having jobs that get retried while the job is scheduled again that's already running concurrently. That's a situation that's bad. Again, experience. And kind of other things is like, you have jobs that fail terminally. Don't retry those. Sidekiq retry in implements that if you have a new enough versions of Sidekiq in your project. And if you don't, sorry, but upgrade if you can. And sometimes you have jobs that are like, if it gets retried after 10 minutes, it's worthless to have done it to begin with. Don't retry those, like just customize the retry policy so that it doesn't try to run it 3 days from now if it's only going to be valid 10 minutes from now or whatever. So the sixth lesson, Sidekiq is not the only system out there. It's complementary with a lot of systems, and you're not going to be able to say like you pick one. They all do different things. They all are really good, and use whatever the best tool for the job is. And so Sidekiq is like the best whenever it's like you want to do work in Ruby later from within Ruby, and that's what you want to do. If you want to schedule a job from a Java application and then run it in a Ruby application later, probably not the tool for you. But maybe Factory would be, right? Like Factory is a lot like Sidekiq architecturally. It has some neat features like progress tracking. Might be a thing that in hindsight I would have used, but I definitely have considered it. I don't know if I would use it or not, but I would definitely consider it. But if you're going to use these other systems, don't use active job extractions because you're using these systems for the special features, and you don't want to let those special features disappear, because what's the point in doing that, right? So what are those other systems? What do they do for you? There's, sort of the high level ones are Kafka, SQS, and, AMQP or whatever. So Kafka is a rewindable log. Consumers are going to track where they are in the log. They're transactions, so you can have exactly one semantics, and really Kafka is bad at the things Sidekiq is great at. Like you can't really reliably execute individual jobs in Kafka because it costs a lot of resources to acknowledge individual messages. So instead you want to like acknowledge a batch of them, and what happens if some fail, right? That's not like it's not particularly great at that, where Sidekiq is particularly great at that. Also, I'll plug Kafka. It's a really great processing framework. Highly recommend using it if you're using Kafka. If you're using SQS SNS, which you might be using in addition to Kafka, like, one thing to keep in mind is that you can really only have one consumer per queue. So if you need to have two different like things that don't do the same thing, you have to have two queues and use SNS to fan out to two different queues. Typically, I've been using SQS to do like fan messages out over to Kafka, or queue Sidekiq jobs in some rare situations directly, but usually it's to just process it entirely on AWS using Lambda. And that's what most people do. But again, all of these are All these are things that you're going to, probably have 3 or 4 different tools in place, right? AMQP, MQTT, that's a telemetry thing. Most of the time, an AMQP message or MQTT is not going to actually be like a job that needs to be executed. It's going to be an observation or a set of them. And, there's a whole bunch of different semantics that are possible. There's a whole bunch of different, it really depends on like software involved. And it's not really the same thing as any of the other things. So like, for instance, you might have your AMQP queue or whatever, you might have that queue process your messages and use something like Apache Flink to process the messages rather, and like submit the observations, like here's what action items, right? Send those to Kafka and then use Kafka to consume the Kafka topic to then schedule Sidekiq queues or Sidekiq jobs. That's a thing you might do in that situation. And so it's not, again, you might run every one of these or even more, and it's all totally reasonable. So what's the 7th lesson? The last one is to pay Mike. Sidekiq Pro. Yeah. Sidekiq Pro is worth it. Like it's really, there's a whole bunch of cool features besides the fact you're supporting the development of it and the fact that Mike can be the person leading this track and all that, right? Like besides that, like it's Sidekiq Pro has a bunch of cool features. It also solves some licensing issues if you work in a company that doesn't like the LGPL. I think it's easy to comply with, but that's my opinion, but not the opinion necessarily of corporate legal. So yeah, it makes it really easy to deal with that because now you're paying for it and they don't care. Superfetch is really good. Reliable Push is really good. Both of those would be on their own individually worth it. Batches are useful, again, worth it. Enterprise, maybe this applies to you, maybe it doesn't, but it checks all the compliance boxes that nobody really wants to deal with. But it's one of those things that you might have to, or you might just roll your own, but like it's a lot easier to just do enterprise. And it's also has a bunch of other features like the SSO thing I mentioned earlier. And really that's the main takeaway from this, is that it's really worth it to get Sidekiq Pro at the very least, particularly if you're at scale. That's what we run. We don't need the stuff in enterprise because we've already had to deal with, like, before enterprise existed, we dealt with the compliance stuff. So anyway, that's the end. I don't know if I'm over or not because the clock stopped working. But this is all my socials, and I will probably upload the thing to my website at some point, but I didn't think about it, and so it won't be until I'm back home. So next week sometime, whatever. I don't know if we have time for questions. If you have questions, shoot them. If you don't have questions or whatever, I have stickers, more than just the 2 that are on the screens over there, not more than the ones that are on the screen. If you're interested, I've got them in big size, small size. Only thing I ask is if you put my character somewhere interesting, send me a picture. I'm in the Oakland Coliseum. So anyway, so that's, anybody have questions? I didn't look up. Oh. Yeah, so the I guess it's really just an observation that if you're trying to fault isolate, then when you have a job that's like 30 minutes or 30 seconds rather, and you have like 5 jobs and you don't want them to be able to compete for resources and you isolate them, right? You end up with what you said, like 30 seconds A, B, C, D, whatever. It's really hard to reason about that. And I agree. And so the thing I left out is that in practice, we'd sort of just have our queues not named the time, but rather the function. So like we would have like listen tracking, for instance, and everything listen tracking related is going to take a certain amount of time, and that goes in one place. And that said, though, at some point that becomes really hard to reason about, and it would be way better if I could say like something like delivery underscore 10 milliseconds and then delivery underscore 5 seconds, because there's kind of 2 things that are the same thing but different, and some takes longer. And so that would be better, but there's a certain inflection point where it makes a lot more sense to just do what I did and name them sort of not the way that Adam suggested. And I would say that like at a certain scale, it gets to be really annoying to have to deal with oh, how long does this queue take? Which queue should I put this job into? I don't know. I put it in this one, and now you're creating the problem you tried to avoid to begin with because you have like 50 developers, and it's just super hard. So anyway, that's my thoughts on that. But like, I totally, yeah, I didn't. It's a lie of omission, is what that is. Yeah, totally get it though.
Thank you. Thank you. That concludes our
Oh.
morning program. Please enjoy your lunch.